You're very welcome to episode number 2 of Binge Watch Academy Superhero Science. And today we're going to be talking about genetic engineering, and we're going to be focusing on a couple of superheroes who you may be familiar with or may not be. But don't worry, I'm going to introduce who they are over the first few minutes of this presentation and event. So just to give you an idea of what Binge Watch Academy actually is, well, first of all, this is what it comprises of. Some of you may have been here for the first episode, which is on March 14th, and as part of that event, we looked at Luke Cage and Superman and impenetrable materials. As I say, this is episode number 2. Thereafter, we have 2 more episodes. Episode number 3 is going to look at Supergirl and The Flash, and episode number 4 is going to look at Daredevil. And actually, at the moment, I'm currently binge-watching the Daredevil series once more on Netflix. In addition to the episodes, there is also a podcast. Now, this podcast has recently been started. There are currently 5 episodes of the podcast online. There is motivational podcasts for the whole Binge Watch Academy series. And before every episode, you will hear a podcast about what you're going to hear in that next episode. And after the episode, you will also get a post-podcast review of what the speaker spoke about. So all the speakers you see on stage here today, well, they're going to say a little bit more about what they spoke about here today and things they didn't get a chance to tell you about on that podcast. And that podcast should be released within a week of today's event. So stay tuned online next week. You can get it on castos.com. It's also on iTunes. It's also on Spotify. And I'm going to put it up on SoundCloud as well over the coming days. What we want is you to spread the word about Binge Watch Academy, because this is an event brought to you by both Studium Generale and BW Science here at TU Delft. And we want to get as many people talking about Binge Watch Academy and what it stands for. Well, it stands for 3 things: superheroes, science, and binge watching, all together in the title. And we'd like you to share this information online. So if anyone is using Twitter or is using Instagram or whatever, please use some of these names and hashtags just to spread the word to people, to get it out there, and people can be aware of what we're trying to achieve here. We want to make people aware of what scientists here at TU Delft and outside and all from other disciplines are doing, and to give you an impression of that using superheroes. So who am I? My name is Barry Fitzgerald. I am a research scientist based here at TU Delft, but I'm also a bit of a nut when it comes to superheroes and the science of superheroes. And I've been doing and involved in scientific research on superheroes for the last 2 or 3 years. I've written a book on it. I've written papers on it. I've even got an open access journal here at TU Delft. The journal is called Superhero Science and Technology, where papers from current scientific researchers are written about superheroes to motivate their work. And they are free to read and free to download, so anybody can have a look at those, no matter where you are in the world. Now, before I start off with the event, I thought I would do something called like a superhero news roundup, just to kind of give people who maybe aren't the biggest superhero fans or haven't seen all the films, just kind of a grounding of what's coming up. But also because, well, I follow all this stuff and it's nice to talk about it. So first news item, just want to point out, is that we are closing in on the 80th birthday of Batman. Now, Batman, the first issue of Batman or Batman Story, well, that came out, you can see it on the slide there, May 1939. So it's happy 80th birthday to Batman. So he's got a very monumental birthday coming up for him. And he's been known by many different names: Dark Knight, the Cape Crusader, the greatest detective in the world. However you know him, he's an iconic character. Also, this film got a bit of coverage today online. I got to say, I got frustrated by it because not only was there a brand new clip dropped online for Avengers Endgame, the 22nd film in the Marvel Cinematic Universe, but all of the cinema websites in the Netherlands crashed because people were trying to book tickets for this film, because the tickets went on release. I had a little bit of a panic during the afternoon, but don't worry, I got my 2 tickets. I'm going to see it at midnight, and then I go to see it at 10 o'clock in the morning the same day. And then I'll probably go see it the following day again. This is what I take and binge watch to another level. These are, by the way, are the Lego sets that are going to be coming out to promote the film. They're really cool. I actually collect the Lego sets from the superhero films, so I'm going to try and get my hands on these as well. And last of all, I should highlight a film that's coming out very, very soon. It's actually going to be out in a couple of days' time. This is Shazam. It's a DC character. I think it looks really cool. I've heard the film been described as a crossover between Deadpool and the Tom Hanks film Big from the late 1980s. So if it merges those two in the way that I've heard about, I think it's going to be a fantastic film. Now, what I want to do in this whole episode and these talk series is to bring the audience into this whole experience. And that's where we have interactive questions. Now, I did this in the first episode, and I've improved, I hope, the system. So what we're going to do is we're going to do an interactive question that involves you using your mobile phones. So what I want everyone to do is to, if it'll come up, there we go. So here is a question where I want people to get interactive with. So I'm going to borrow on the Batman thing I mentioned at the start. If you go to menti.com and you put in the code 392761, that question will appear. And the question is this: I want to know, who is your favorite Batman from over the years? Now, I've left out two actors who have played Batman, although there's been a couple of others as well in cartoons, but I've left out 2 actors, and this is nice. We're getting a very interesting, you can just vote away here until you're going to vote once, by the way. And I don't think any of the speakers brought their phones with them, did you? Oh, you got your phones? You can vote too. You don't have your phone with you, no? Do you want your phone? Are you sure? There's going to be other questions. Whose phones have I got here? There's another phone here as well? Yeah, there you go. You're welcome. Right, this is fairly clear regards to who the favorite Batman of this audience is. I think everyone has voted more or less at this stage. Yeah, pretty conclusive. 31 Christian Bale. 9 for Ben Affleck? No comment. I'm so disappointed. 4 people went with Michael Keaton. Because Michael Keaton's my favorite Batman. Who went with Michael Keaton? Hands up. Great. 2 other people who don't want anyone to know about it. And 2 for Adam West, the old classic, cartoon-esque Batman. And then someone else. So I assume the people who went for someone else went for either Val Kilmer or George Clooney. Or is there somebody else that I'm forgetting about? Yes? Kevin Conroy in? Oh, the animated series is, of course, yeah. And there was also some actor playing him in the DC series Titans, but I don't know who that was, but you never see his face. Right. There we go. It's really nice to see the interaction. There'll be some more questions like that over the course of the talk series as well, over the rest of the evening. And I just need to do that and then that. So let's get on with the content of today's show. So what we're going to do is we're going to talk about genetic engineering. I'm going to use 2 characters as the platform for this. So very quickly, first one is Jessica Jones. That's Jessica Jones. You might recognize the actress from Breaking Bad. Christian Ritter. And this character may be unknown to many of you, and you may be wondering who she is and what kind of powers she has. Well, she's got super strength, like lots of them, but she also can jump very high. Effectively, she can jump buildings. And she's also teamed up with a bunch of other superheroes that have been the focus of, or will be the focus of, Binge Watch Academy Superhero Science. So she's worked with the Defenders. So that's Luke Cage, who was in episode 1, the Iron Fist, and Daredevil, who will be part of episode number 4. The second group that may be touched upon is the X-Men. Now, the X-Men are a group of mutants. Now, in the case of Jessica Jones, as you'll find out later on, her DNA was changed in some way. But the X-Men are a bunch of characters who were born with a mutation. And this mutation led to the development of superpowers. And later on this year, you'll have another X-Men film, X-Men Dark Phoenix, will be coming out over the summer. And this is Sophie Turner playing the lead role, that is Jean Grey, or the Phoenix, with 2 of the other prominent actors in that. That is Michael Fassbender and James McAvoy as Professor Xavier and Magneto. Now, the issues, well, they have contrasting first issues of these comic books. I pretty much do like the classic X-Men #1 from 1963. It gives you an idea of the era of when these comic book characters were all being created. Funnily enough, 1963 was also the same year that the first Iron Man comic book appeared and Spider-Man. So Marvel Comics and Stan Lee himself had a really properly creative run of excellent characters that year. The Jessica Jones character, only around since 2001, appeared in an adult Marvel Max comic book series. And if you've seen the Jessica Jones series, you'll know that, well, some of the content in that series in particular is very much adult orientated. Now, tonight's topic is on genetic engineering. And what we're going to be talking about, well, not me, what the speakers are going to be talking about, is the various different aspects you need to be taken into consideration with regards to the connection between genetic engineering and superheroes, because many of these characters have undergone some sort of genetic mutation or change that allows them to have the powers that they have. Now, to start things off and to introduce you to what many see as the game changer in genetic engineering, that is CRISPR-Cas. Well, the first time is, that slide shouldn't be there. The first speaker is Charlotte Koster. She is a PhD researcher in the biotechnology department, is that correct? Yes, here at TU Delft. And she's going to introduce us to CRISPR-Cas and also some of her work that she's doing here at TU Delft. So a round of applause, please, for Charlotte Koster.
Let's just So thank you very much. Today I will be talking about CRISPR-Cas, obviously. It's something I use in my work every day. And I will try to explain how we can use CRISPR-Cas to turn a regular girl like me into a superhero like Jessica Jones. So the field I work in is called synthetic biology, and you might not be familiar with this. Synthetic biology, in this field, we basically see a cell not as this living, dividing, mystical thing we don't understand. We try to see it as a machine, as something that is wired and it has components, and we can change those components and we can rewire the cell, just like you could rewire a radio or a television. However, rewiring a cell is a bit harder than rewiring a technological device. If you want to change how a cell functions or how a whole organism, like a human person, functions, you would have to look at the blueprint of that organism or of the cell. And that blueprint is called DNA. DNA is basically a really long molecule that is made up out of 4 smaller molecules, and we call them A, T, G, and C. And the order of these A, T, Gs, and Cs determines how a cell functions. So you can kind of compare it to binary code, where in a computer, the zeros and the ones, they determine how a certain software runs. In a similar fashion, the order of A, T, Gs, and Cs in your DNA determines whether you have blue eyes, or whether you have dark hair, or if you're tall, all that. And by changing the order of these A, T, Gs, and Cs, we can also change the function of a cell. So, for example, we can change your blue eyes to brown eyes, maybe. So what would we have to change in these A, T, Gs, and Cs in order to turn a person into Jessica Jones? So she's known for her super high jumping capability, and she can also regenerate wounds really quickly. And I was asked for this talk to kind of think about how would I, as a scientist who uses CRISPR, approach this. And I actually got helped by the producers of the Netflix show Jessica Jones, because in season 2, Jessica goes to find her origins, and she stumbles upon a stack of research papers. And one of them mentions a gene editing technique called CRISPR-Cas. And the cool thing about this is that this is not made up by the producers at all. This paper is an actual research paper. So I read it, and unfortunately it's not about how to turn someone into a superhero. It's about bacteria. But it's nice to know that Jessica was made by CRISPR. Well, I can tell you a lot about CRISPR because I work with it, so I will shortly explain how this works. And if I had to explain CRISPR to you, I think to stay in the subject of superheroes, I would like to compare it to a superhero, or more of a villain, the Punisher. The Punisher is a hitman. And if I think of a hitman, I think of some big guy you go up to and you show them a photo of someone you want dead, and you tell them, here, I want this person dead. The hitman will take that photo, go out in the world, find that person, and he will kill him. CRISPR works surprisingly similar. CRISPR is a molecule, and you can feed that molecule a piece of RNA, which is a different form of DNA. CRISPR will take up this RNA, it will go into a cell, and it will find the piece of DNA that matches that RNA. And when it finds that piece of DNA, it will destroy it. And then we, as scientists, come in and say, oh no, the DNA is broken, and we will fix it. And we can fix this DNA any way we want. So we can change the order of the A, T, Gs, and Cs. For example, we can make bacteria that can produce insulin. And scientists have worked on CRISPR a lot. This used to be a system that only worked in bacteria. But now it also works in yeasts, and it works in plants, it works in fish, and it even works in humans. And you might recently have heard about a Chinese scientist who says he genetically engineered 2 babies using CRISPR in order for them to become resistant to HIV. And I don't really want to talk about whether we should do this, because that will be the topic of the next talks, but I actually want to talk to you about, can we as scientists do this? And the answer to that is, don't overestimate us. Because cells are so insanely complex, we don't really understand yet what the effect of CRISPR is going to be on a cell. Also, if you want to engineer a human like me, who is already fully grown, it would mean you have to get CRISPR in every single cell of the body, and that is actually insanely difficult. So right now the answer is no. We cannot design superhumans and superheroes. But we kind of try to circumvent, because we still want to do research on CRISPR, and we kind of circumvent this by going to a simpler organism. And in my case, that's yeast. I study yeast in the lab, and we use this organism basically because it's surprisingly similar to humans. We can put human DNA in yeast. We can even give yeasts human diseases like Alzheimer's and Parkinson's. And therefore we can use yeast kind of as a testing ground for genetic modification. And for example, a colleague of mine, Arthur, he's actually here today, he discovered that sometimes when we try to change something using CRISPR in yeast, the repair doesn't really go as planned. And instead, you can awaken, for example, dormant diseases. And we discovered this in yeast, but there's a really high chance that it actually translates directly to humans. And there's a really easy fix for it, but we first have to know that these kind of errors exist before we start modifying humans in order to become superheroes. But let's just forget about all that for a while, and let's just say we're 100 years ahead in time, and we are finally able to genetically engineer humans, and we can make superheroes. What would I have to do to myself to turn myself into Jessica Jones? Well, the cool thing about biology is that basically if something exists in nature, you can usually take it from one organism and put it in the other. So all we have to do is just look at all the variability out there in nature and find someone or find something, some animal maybe, that can do something, and see how we can transplant that into humans. If you take Jessica's super high jumping ability, for example, we could look at the organism that can jump the highest in the world, which is the tree frog. This animal can jump 150 times its own length. If I could do that, I could jump 250 meters up in the sky, which is pretty high. And the secret of the jumping ability of this frog is not in its muscles or in its immense strength, because it's really a really tiny thing. The secret is in its tendons. So this frog has elastic tendons, which means that if it jumps, it can kind of spring itself up in the air. So if I would like to change myself into a Jessica Jones using CRISPR, what I would do is I would delete all the genes that say what material my tendons would be, and I would replace them with genes that say, or that encode for the material of the tendons of this frog. And maybe my muscles will then have elastic tendons and I can jump really high. Jessica can also regenerate her wounds really quickly. That's a bit more challenging, but even that is already possible in nature. I would like you to meet the axolotl, which is a really cute salamander that can actually regenerate its limbs. So if you cut off an arm, it will just grow one back. And for us humans, that's not possible, because our cells have a fixed role. Once a cell is a skin cell, it will stay a skin cell forever. But that's not the case for this animal. It can kind of change the role of its cells. So if you cut off its arm, the cells in the wound will turn into arm cells again, and will then turn into hand cells, and the arm will grow back. And scientists have actually already been able to, or have been trying to reproduce this in the lab with human cells. And they've actually already come a great way, which is great news for people who have lost a limb or need to grow a tendon. However, this sounds very science fiction already, but I don't want to stop here. Because a big part of my research I'm doing in lab is a project called Building a Synthetic Cell. And we are actually trying to, in the lab, build cells out of nothing, about molecules. And this cell is not going to look like any of the cells we already know. We're going to see if we can optimize it. And that means we might take the DNA from yeast, and we might take the cell wall from bacteria, and we might take the energy system of plants. And we can all put that together into a cell that has never existed before, but will become a new life form. And so actually, if I would have to design a superhero, I would not try to take an existing woman and turn her into Jessica Jones. I would go further. I would make the Vision. The Vision is this awesome synthesoid, we call it. He's kind of half robot, half man, half everything, which is much like the cell we are trying to build in the lab. And you can actually see that he was inspired by both nature and technology. He has this cool rock on his head that can convert sunlight into energy. That is very much like how plants make their energy using photosynthesis. And also, he probably doesn't have DNA, but uses binary code. But who says that the A, T, G's, and C's of our cells cannot be zeros and ones? He will probably have neurons because he has feelings. But then again, you could paste those neurons on a skeleton. The possibilities are endless, and therefore this is actually my favorite superhero. However, we keep always, when we talk about CRISPR, the conversation always diverts to, can we make superheroes? Can we make designer babies? Can we do everything with the human body we've ever wanted? And I actually think that overshadows the actual superpowers of CRISPR, because CRISPR is so much more powerful than that. When CRISPR was discovered, all scientists basically dropped what they're doing and started using CRISPR. And that has sped up the speed of research so insanely much, and it has helped us to understand cells so much better. And in the future, CRISPR can maybe be used to generate superheroes, but most importantly, we can maybe cure diseases with it, or maybe solve the world's problem with using chemicals instead of biological agents. So in that sense, I think CRISPR has a lot more to offer than just making superheroes, although that is also really cool. So that brings me to the end of my talk. I would like to thank you for coming here and learning about CRISPR, because I think it's really important that people understand more about it and see the awesome powers of this tool. And there's some room for questions now, and otherwise this is my email address. If you want to know more about these rainbow yeasts or just about CRISPR in general, please send me an email and I'm happy to discuss it. Thank you.
Brilliant. Thank you very much, Charlotte, for that very interesting talk. And there is the little question marks on what are these in the image?
So those are yeasts, and they're expressing 3 different proteins that they're fluorescent proteins. So if you shine light on them, they emit a color. And they have green and blue and yellow, and I was trying to image different parts of the cell.
Very nice. Very artistic. Yeah. Lucas, what would you say?
This is real bioart.
Yeah, it's an image. Questions then, regards to what Charlotte has spoken about. Does anyone have any questions? Yeah. You ready for this? Yeah. Oh, almost. We should give the audience crash helmets, I think, for this, right?
Well, it's soft.
It is soft.
Yeah, thanks for the insightful talk. I wanted to ask that, how do you change the order of ATGC through chemical reactions or something else?
No, so we do that with CRISPR. So we send out the CRISPR molecule to destroy the DNA we want destroyed. So for example, again, if you take the example of the frog muscles, what you can do is take a human cell and send CRISPR to break the genes that tell how a muscle looks like. And CRISPR will break it, and then we as scientists, we can repair it by just actually adding a piece of DNA to the cell. And you can repair it using, for example, another gene from a frog, and then you get frog muscles instead of human muscles, for example. It's really like simplified, but
Okay, yeah, thanks.
Any other question? We'll take one more question. Yes, right down the middle.
You talked about synthetic life, right? So did you manage to make any cell?
no, it's actually a 10-year project, and we hope to achieve something. It just started last year. So right now, we do have parts of the cell working, but the difficult part is to put it all together and like make it stick together mostly, because there are still some parts of life that we just do not understand why we have them, but we need them. And right now we're at the stage of figuring out which parts do we actually need, which parts don't we need at all, before we start putting everything together and build a cell.
Yeah, so then comes, so if you are able to assemble everything, can you actually bring life to the cell? Like it's just a bunch of chemicals, right? So
yes, so
how do
that's
you...
a really interesting ethical debate, because some people believe that a cell needs more than just chemicals. Personally, I think everything is driven by physical reactions and chemical reactions, and in theory, you should be able to put those molecules together and make life. But that goes back to the origins of life. Like maybe there was a God like saying, here's life, or maybe it was just a bunch of chemical reactions, and we hope to find out a little more about that, and if we can just put molecules together and make life, or if there's actually something extra needed to bring life into a cell.
Okay, sure.
That's great. Thank you very much for your questions. Another round of applause, please, for Charlotte and her great talk. Thanks a lot. Okay, so just a little break. We're going to have one more question based on what you've just heard. So if you just get your phones out, you don't have to change anything. There's nothing about going to another website. So it's the same website, same code. So the question here, which is kind of motivating what we're going to hear from the next speaker, is should we modify human DNA to create individuals that might have superpowers like Jessica Jones? So the options are yes, sounds good, sign me up. No way, too much remains unknown. I'll have a think about that. So I'm letting people sit in the fence on this, because people like to sit in the fence sometimes with these type of questions. Oh, this is a real... Wow. Such as? This is a very kind of surface question. I completely agree with you that there's more that can be added in. But when you have like 20 seconds, you want to make it as easy to read as possible. Everything you just said, I totally agree with you. Right, have we got everyone voted? 64 people, wow. So potentially a lot of unethical people in this room. Right, so our next speaker is going to motivate the ethical arguments and the ethical side point, which is very much important when you're talking about genetic engineering. To be honest, it's important for all areas of science. And the next speaker is going to be Britta Bouchon. Is the surname pronunciation correct? Good enough. From Biotechnology and Society, yes, here at TU Delft. And, well, she's going to talk to us about bioethics and give us an introduction to the topic. A round of applause, everybody, for Britta. There you go. Let's move forward here.
This one?
Yeah.
Great, thank you. Okay. Good evening, everyone. Can everybody hear me? Yeah. Okay. Well, thanks. First, I want to thank you all for being here. So, as Barry already introduced me, my name is Britta. I'm a PhD researcher at the Biotechnology and Society group here at TU Delft. And this evening, I wanted to share some of my ideas and thoughts that I have associated with CRISPR-Cas technology, and what are the things we should take into account, and what things should we consider for the future implementations of CRISPR-Cas technology. So I'd like to kick off with a quote of John Adams that I really like. Risk is a word that refers to the future. It has no objective existence. The future exists only in the imagination. Well, to the people in the audience that are already familiar with risk assessments, this quote may sound a bit odd, because in our daily lives, risks are quantifiable and we can use them within risk calculations. But the word risk in this quote, it refers to unknown risks, uncertainties. So could we ever know these when they are, well, when they might or may not happen in the future? Is it really necessary to take things into account that might not even happen? Well, what if the future is suddenly here? As Charlotte already introduced, in November 2018, the Chinese researcher He Yang-Qiu, and I don't know if I pronounced his last name correctly, he announced that 2 babies were born that were genetically modified. Lulu and Nana's genes were altered in order to prevent them of becoming infected with HIV, of which their father is a carrier. Well, although it has become very clear that CRISPR technology may not have been necessary in order to prevent them from becoming infected with HIV, it has caused a lot of discussion, not only about the consequences of being treated with CRISPR technologies for the babies themselves, but also what this means for science, but also for the regulation of science and for society itself. Well, in essence, we could argue very basically that if we are able to heal diseases of people or people that are not born yet, beforehand, this could be ethically justified because it can prevent a lot of harm to be caused by the diseases. And also it would increase a lot of happiness of the families and the peoples themselves. So if this sense it would be ethically justified, should we therefore also accept it as a society? And if we would accept diseases of being prevented using CRISPR technologies, would it also be justified if we would use it for more aesthetic purposes? Because you can argue again, this might also increase one's happiness. Well, this brings us to the topic of human enhancement. And human enhancement in this presentation, I mean it in a very broad sense. So basically, it means you can make modifications to your own body in order to gain something, to achieve something, and whether those are just other character traits or super strength. So, for example, an example of human enhancement could be that you can implant a chip under your skin, and it could give you information of your body's vital functions, and maybe even a disease that is developing itself within your body. And in a way, we are already doing that. Does anyone of you here wear a smartwatch or a wearable? Can I see some hands? Well, I have one too. And in some way, this is already giving us a lot of information throughout the day. So we could argue that it's just a very small step in order to gain some more information about our bodies. But with human enhancement, we can also think of other things. It can also be gaining superpowers, which is more in line with the theme of this evening. Super strength, becoming incredibly fast, or maybe even becoming visible. And also, from an ethical perspective, we might say that, based on autonomy, we have the right to decide on our own bodies what we want to do with them, and it should be okay. People should be okay with that. If I want to alter my body, that should be okay. But what if we take that one step further, and we are not only deciding on our own bodies anymore, but also for the bodies of our unborn children, designer babies? Would this be okay? Would it be okay to just choose the eye color of our unborn child? Or maybe the color of their hair? But what if we could also choose other character traits, like fine motor skills, giving them the chance to become an incredible pianist, or maybe an excellent athlete? Would that be okay? So, here's Jessica Jones again. So, initially you could think that CRISPR technology can bring us all marvelous stuff and that it's all positive. But applying CRISPR technology can also come with some unsuspected outcomes. Here, I do not want to focus on Jessica Jones, but I want to focus on the guy standing next to her, Kilgrave. When Kilgrave was just a child. He was called back then Kevin Thompson. And Kevin was suffering from a neurological disease. And his parents in the series, both neuroscientists, developed an experimental gene-altering method in order to cure him. Well, eventually, they treated him with the experimental technology, they cured him, but it also traumatized the boy. And in addition, besides the trauma it caused, it also gave Kilgrave, as he referred to by himself, it also gave him the capabilities of leading others' minds, guiding others' minds, their thoughts, and what actions they're going to take. So this is very illustrative that although the parents of Kilgrave experimented on him and treated him with the good intentions of curing him, it did cure him, but it also came with a lot of negative outcomes. And of course, it was his own decision to use his capabilities in a bad way instead of using them in a good way. Are there any Star Trek fans present here? Okay, so you're already familiar with the person on this picture. Khan is a character from the early Star Trek series. And Khan is also a genetically modified human during his time back on Earth. Well, during his time back on Earth and when he was altered, things got a bit out of control and eventually they decided to shoot him into outer space. Well, after 2 decades of floating around in outer space, Khan and his crew, or his followers, were picked up by the USS Enterprise. On board, Khan got a bit out of control again and tried to take over the Enterprise, which failed. Afterwards, Khan and his followers were put on a different planet and they were given the assignment of repopulating the planet. Well, unfortunately, 6 months later, the planet exploded and Khan was homeless again and full of wrath, and he wanted to take revenge on Captain Kirk. So he followed him around the universe, he found him, but eventually also that didn't work out and Khan died. Well, very sad, but what does this story tell us? It tells us that although you create a superpower or a Superman, it doesn't always turn out to be that super after all. So all these sci-fi scenarios, what does this actually mean for modern biotechnology? Well, also due to the discovery of the different applications of CRISPR-Cas technology, the developments within this field have increased tremendously. And not only the number of developments, but also the pace they have been developing. And as a result of this pace and the developments, current regulation is falling behind. Well, what we're trying to do now is to create an update for current regulation in order to develop and regulate upcoming biotechnologies in a safe way. That's also what we're trying to do at the Biotechnology and Society section. We're working with a lot of different people, all with different backgrounds. So we have people with engineering background, we have philosophers, biologists, and also people with a background in political sciences. And together we try to figure out what it is that can actually make new technologies be successful when implementing them in society. When we're dealing with developing technologies, we often have to take into account many different persons and all with very different opinions about the technology in question. For example, if you look at this picture, and in the case of GMOs, one might think that this is an excellent idea and it could solve our world food problem. Another one might more see it as a neutral technology. And yeah, well, it's nice to adapt food in a way that it might be a bit healthier or longer preservable. And the third one might be scared to death of the technology and is trying to avoid it as much as possible throughout their lives. So how can we regulate for safety when there are so many different opinions and perceptions of what should be safe enough? And maybe not even safety, but also risks, unknown risks, and uncertainties that come along with that. In my ongoing research, which is called TTRIP, the Tools for the Translation of Risk Research into Policies and Practices, we try to do this for the biotechnology and synthetic biology domain. We try to take into account the whole biotechnological innovation chain, of which you can see a very simplified version here. For the purpose of clarity, as I mentioned, we often have to deal with a lot of different people. So we try to divide them into 3 different levels: the technology level, a policy level, and a society level. And although all of these levels work independently, they also interact with each other. Technology influences policy, policy influences society, and the other way around. Each layer affects the other one. So when we take this whole picture into account, we still have to, we're still dealing with different people. For example, I'm referring to the word actors a lot, and with actor, I mean someone who is involved, so an individual or a group who is involved within this innovation process. So for example, somebody working in a regulatory setting, so making the laws, or in a governmental advisory body, might see an arising issue when scientists working on the genetic design or the development of the organism itself. People working in academia, so a researcher, a scientist, or an engineer, might see an issue rising during the build and test phase. But maybe people working in industry might see an issue in terms of safety or risk in terms of the scale up within the innovation process. And people from society, the bottom one, might see issues with the technology in question when the technology reaches the market. So, how can we create regulations that take into account all of these different opinions and perceptions and ideas? Well, that's quite a challenge, I must say. And the thing is, well, we're working on this, well, for the next 3 years. And I do think that it's very important to take into account different perceptions. We're all working together, trying to create a better world, and therefore we should not let out any other different opinion. So, to conclude, in my perspective, CRISPR technology is a really interesting, wonderful technology which can give us a lot of positive outcomes. But I do think that we should handle it with caution and be aware of how we are going to implement it further and also within the future. I also think that we should not focus per se on the individual human enhancement that I talked about. I think CRISPR has the potential to give us a lot of benefits, but I think we should do it collectively. And maybe it's better to enhance all of our lives together. And I think that's where the true superpower of CRISPR technology lays. Thank you.
Very good. Thank you very much, Britta, for a very interesting talk. We have time for one question, just so we can keep to the schedule. Does anyone have a question for Britta and what she presented in terms of bioethics? Anybody?
Otherwise, it was very clear.
Actually, on the stage, someone has a talk. Yes,
Is that
or a question.
allowed?
Yes, of course.
Yeah. Well, I think that's fantastic research you do, and thank you for your presentation. I'm wondering, you conclude your presentation with that CRISPR is a technology with a lot of possibilities. What was it again? And that we should, and that we should apply it for good. But you didn't say much about what then is defined by good. So you
that's
introduce
a good question.
you introduce a values-oriented perspective without trying to tell us where those values are, what those values are, what is the bias that makes up good.
Yeah, well, I agree with you that good is a very subjective term, and what I think as something being good can be perceived, of course, very differently by you, for example. But when I'm talking about good in my presentation, I'm referring to the greater good, so that it will benefit most people. So we're not trying to focus on the individual gains,
Inclusivity.
exactly, but more the collective gain
Yeah.
for us all. But yeah, I agree. I also think that the future of CRISPR-Cas, and especially the application of it, is still very unsure. We do not know yet how far it will take us and what we might be able to solve with it. But I do hope that this technology will be applied in a good way.
Thanks for the question, Lucas. Thank you very much, Britta, for your talk. It was great. Another round of
Thank you.
applause for Britta, please. Okay, so very quickly, I got another one of these questions for everyone. You can stick on the same website. These are like just strongly agree, strongly disagree. These are just statements that I've come up with in relation to what you've heard. His work on CRISPR babies was unethical. Proper policy and regulation of biotechnology can make things safe for everyone. Bioethicists should be included in the initial design stages of all biotechnology projects. We're getting a very nice live analysis of what interesting. So I think we're almost there. I'm very interested on the first one. I think that's almost basically everybody. Yeah, interesting results. The last statement I completely agree with. I would strongly agree. I'd be 5 on that, but that's me. Of course, this is everyone here. Britta, because these questions were slightly motivated by your talk, what do you think about those outcomes?
I think the first one is really interesting. I do believe that it is unethical, but it doesn't mean that it only has negativity.
Of course, that's a sweeping statement I have there, yes.
Proper policy and regulation in biotechnology can make things safe for everyone. I don't believe that we can ever achieve absolute 100% safety. There will always be risks, but the question should be more, what risks are acceptable?
And the last one?
Bioethicity, yeah, of course. No doubt about that.
If you didn't say yes to that, you were talking yourself out of a position. Okay, you'll have another one of those questions later on in the presentation as well. So just a little bit of science news related to what we just heard. I like to put in these little tidbits. So this Wolverine, we all know about Wolverine from the X-Men, has accelerated healing powers. But earlier this week, a paper was published in a British medical journal about a 66-year-old woman from Scotland who presented with some very unusual attributes or traits. She's now 71 years old, but when she was 66 years old, she went for a hip operation, and she turned down painkillers for the operation, saying that she has never taken painkillers at all in her whole life. In fact, that she only knows if her skin is being burnt when she smells burning flesh. So she also is immune to pain, as I say. But in addition to that, she also has displayed some degree of accelerated healing. So her genome was sequenced and checked out, and it seems to be that, in fact, in her case, one of the genes associated with pain has been effectively switched off. And she does portray some degree of accelerated healing, and she also doesn't experience anxiety or fear. Is she some sort of superhero? Perhaps, in the light of the comic books. Or is she a genetic fluke or genetic mutation? Perhaps that is also the case. The downside, she says, let's say her weakness is that she forgets a lot of things sometimes and forgets where she put the keys for her house once, she said, things like that. So there's a plus side of having this stuff and a downside. That's a real paper, by the way, and you can check it out. So very, very interesting story. The next speaker then is going to come from a completely different viewpoint. So you've heard someone has told you about how CRISPR-Cas works. You've heard somebody tell us about the ethics behind using CRISPR-Cas potentially in many different aspects of society. And then for something completely different, Lucas Evers from the VAC at Amsterdam is going to tell us about CRISPR in art. A round of applause for Lucas, please.
Thank you. Can you hear me? Can you hear me? Thank you, Barry, for inviting me. Thank you also the previous speakers for fantastic contextualization. It's super nice how you are relating your presentations to the story of Jessica Jones. I didn't do that. But it's also very interesting how you, Barry, relate that to science fiction, to stories, because I think stories can do a lot. Stories can carry the whole story of CRISPR because we cannot see it. That is why science fiction comes in, but also art. It plays with imagination, and I'm going to run you quickly through a number of artworks that use gene editing technologies, techniques, and where that takes place. So we are based there. That's an old city gate in Amsterdam, but it also holds a anatomical theater, a historical anatomical theater, where this painting by Rembrandt was painted, talking about ethical, unethical. Probably the patient there didn't give consent to this picture, but it's a very interesting early art-science collaboration that happened in the building where we have a wet lab with a certificate, a permit to do certain genetic modifications. So there's the lab. We do workshops, we do performances, we do exhibitions. We have a lot going on. That project there, working with, what are they called again? EEGs, that's it. We did that with TU Delft long time ago. But also, looking at time, I'm going to show you what's going on. You have a lot of biotechnologies, not only CRISPR, but also let me put this off, sorry. You can print DNA, you can have a synthetic womb where you grow whole mammals in. It makes it more visible than just CRISPR. And there's a reaction by biohackers that are using DNA sequencers to make their kind of non-academic research. Here you see a number of PCRs that are made by biohackers. And here you see a number of artworks that react on what's happening in biotechnology in general. So they're making tissue cultures there. They're working with bacteria that bring gold particles together. Here you see a tissue culture that is made of the tissues of the daughters of the artist Gina Czarnecki. Tissue that she cultured over the glass cast heads of her daughters. So she's doing something dermatological that is very innovative, but also questioning what is the portrait in the times where you can literally use the skin and grow the skin of the person that you portray. And now some more experiments that really use gene editing technologies. One of the first was in 1996 by an American artist that is still on the payroll of MIT labs in Massachusetts, who said, well, there's a lot of stuff brought into space to tell probable intelligent life out there about the existence of humanity, but it's all male-oriented, so we need more female-oriented science in there. So he made a mutation in the DNA of an E. coli bacteria that reflects the Venus there, which he called micro-Venus, and it was meant to be shot with a satellite into space. It never happened, unfortunately, but he really attempted that with NASA. Who knows that artwork? Yeah, it's all about, it's one of the first genetic modified artworks. a rabbit that was given a GFP protein that makes it slightly fluorescent under very specific conditions. But also interesting here is that it makes genetic modifications tangible. Often the general public doesn't see that out of the lab. Yet this artwork does that. On the other side, you see also a gene editing technique that he used, similar to that of the artwork we just saw before. Oh no, where is oh, this is back, sorry. Joe Davis uses viral transfection, and so does Eduardo Koch, who coded a part of the Bible into, again, an E. coli bacteria that you see a colony of, and the slide projection he has in that slide I showed there. Again, another artist using, again, viral transfection, but then to put Article 1 of the Declaration of Human Rights into a yeast or an organism that is affecting apples. This is a work of Adam Zaretsky, who used not viral transfection, but so-called zinc fingering. And he put that in an installation called the Aurarium. It's very interesting what he did. He used zinc fingering not to use a reductionist kind of mutation in plants, but he used it in such a way that it expressed more than just one new feature. So hence he was criticizing by this work scientific reductionism by reversing the procedure there. This is a pretty new work. Again, also interesting because she is using another kind of bacterium that produces a bacterial cellulose, which also makes it tangible. And here she also used viral transfection to put a story into the code, the DNA code of a bacterium. Here you see a real work by an artist that used CRISPR. It's a work of Anna Dumitriou that she made in a program that we recently done with her. She used CRISPR to mutate. But I should tell you quickly the background of the story. She has been working with a lot of dyes to make her artwork. And the dyeing industry also moved into the industry of making pharmaceuticals. So she knows a lot about the history of tuberculosis because of what was it called? The medicine that fights tuberculosis, penicillin. And 1941 happens to be the year that the first penicillin was used on humans. 1941 was also the year in which the British government issued the so-called, what's the name again? The Controlled Commodity Campaign, which meant that you had to repair your clothes because there was war and there were no new clothes coming from the mainland. So what she did here was took a dress that she repaired with textile that she colored with the bacteria that she has been mutating by CRISPR-Cas. And in that sense, she creates a moral message in the artwork that says we have to use CRISPR in a very responsible way. Because if we are going to use CRISPR like we use penicillin, like we use antibiotics, that has been happening in agriculture so much, that causes microbial resistance, then we're going to lose CRISPR as a new technology that can bring us the new means to fight microbial resistance. So that's an artwork that is using CRISPR, but that also contains quite an important moral message, if you ask me. This is the last artwork I want to say a few words about. Made by a colleague of mine, Ronald van Dierendonck, together with an Austrian biohacker. And what they did was use a CRISPR protocol, a CRISPR technique, to again make an image in the DNA of an organism. But you cannot do that outside a certified lab. So what they did was make a cell-free expression. So they prepared a DNA molecule outside of a living organism, which circumvents the need to have permission to make that mutation. And they took, and it's very abstracted here, they took the head of a bull, the image of a bull that they've taken from an area in nowadays Iran that is called Dilmun, which happens to be the cradle of agriculture. And they coded that into a DNA and then recoded it back, and you see that the bull again appears, but with a lot of mistakes of the recoding process, which they don't mean anything with. It's just a proof to say that we have been able to code that bull into that DNA and recode it back. But it's interesting that they make a relation in the artwork with the history of human agriculture. That is so important and actually is a driver for all sorts of new biotechnologies that are out there. I think also the work with the yeast also is related there. Britta was talking about the relation between risk and imagination. I think we need a lot of stories, and I think artists are very well able to tell those CRISPR stories, to bring us a CRISPR aesthetic, to understand the aesthetic of CRISPR itself much better. Also to understand that framework of values that we need to create to make new applications of CRISPR technologies for not only our own good as humanity, but maybe also for ecology, so for the planet itself. And maybe it's interesting to train ourselves in imagining other sorts of applications than the image you were showing, or was that the powerful man with the stone in his head, which is a very exhilarating figure. I'm always dreaming of using CRISPR, for instance, to research whether we can hibernate like other big mammals do. And by letting whole humanity hibernate, lower our footprint on the planet. I thank you for listening.
Thank you very much, Lucas. Does anyone have any questions for Lucas? We'll take one question from the audience. The catch box is somewhere out there, I think. It's right there. Does anyone have a question? I have a question. Do you have any art pieces like this in your own home?
No.
Would you like to have art pieces like this in your own home?
Well, I would love to have. This is one I didn't tell you about, but I would love to have this one.
Okay, it's got an interesting title.
It's a speculative artwork of a Taiwanese artist that made a tiger penis that he wants to make in vitro.
Right.
in order to stop tiger poaching for penises, because there's a high demand in Chinese traditional medicine for tiger penises, because it makes men more manly. And I'm challenging him to go to a zoo, to ask the zoo to take a tiger penis biopsy,
Right.
and then use IPS to create tons of tiger penis tissue in a laboratory, so that we don't have to kill tigers.
So it's got a positive impact on the animal kingdom.
Yeah, but it's, yes.
Okay.
And I think there is a lot more to imagine that we can do with techniques such as CRISPR.
Well, very, very interested. Another round of applause for Lucas, please, for his great talk. Right, I got one more question, which is kind of related to the question I just asked Lucas, which is this. And would you hang CRISPR-Cas art on the walls of your home? So if you were told yes, we have very much got lots of yeses here, which is good. Some people think it's weird. Some people think that they're not sure. That's okay. We got like, wow, okay. Excellent. So basically, majority is yes. Then we have, and the next group is they're not sure, and then we have the lowest bin, no. I think it's weird. I think art like this is really, really cool, and I'm going to show you why I think it's cool, because I kind of got into this a little bit, because this is a bioart piece I have at home in my own apartment, and there are 3 biological components in this. So you have the red things, the white things, and the blue strands. The red things are red blood cells. The white things are white blood cells. Does anyone want to tell me what the blue things are? Only 3. Nice. Only 3 people have ever told me the right answer. One of those was a 6-year-old boy in Ireland. So there you go. Anyone want to guess? Yes? No. No. Think outside the box, and then think outside that box. Yeah. Sorry? I couldn't hear you. Cotton, no, but that's great. You're thinking outside the box. One more go. No.
Is the protein of blood clots?
Oh, the fibrin? Yeah. No. It's spider silk. And they're not just any red blood cells and white blood cells. They're my red blood cells and white blood cells on top of spider silk, taken underneath a scanning electron microscope. So a friend of mine does this, and he just took my fingerprint as well. So he's going to do the same thing with my fingerprint and color it. This one was colored like Spider-Man or Captain America, whichever one you want to look at. I'm getting the fingerprint colored as Iron Man. So that's, I'm open to this art. I think it's really, really cool. Right. The last speakers are 2 people I know quite well, because we've done some work together. Florence and Laura, I had the privilege of working with them on a project as part of the minor in responsible innovation, which is shared across TU Delft, Leiden, and Erasmus Rotterdam. And as part of the project, they worked on CRISPR-Cas. And I have to say, it was an absolute pleasure to work with them, because they were just so enthusiastic and came with such great ideas and a completely different perspective to things. So to tell you all about what they did, I want everyone to have a nice round of applause for both Florence and Laura. There you go.
Hello, everybody. Thank you for coming. Thank you, Barry, for having us. So I'm going to tell you first something about the project that we did with Barry, and then Florence will tell you something about how CRISPR-Cas relates to the value of human rights. So our project was all about the ethics about CRISPR-Cas. It kind of relates to what Britta told. Barry initially wanted us to look at de-extinction, which is bringing back animals from extinction using a gene technology, such as CRISPR-Cas. But we decided we didn't want to stay there, and we wanted to look at more applications, applications that are being done right now, but also applications that are possible and maybe in the near future or in the far future. Something that has been done in the recent years was, at the right bottom you can see a mosquito. So scientists discovered a way to use CRISPR-Cas to eradicate malaria from these mosquitoes, to maybe solve the malaria problem. And also scientists are currently using CRISPR-Cas to make disease models in rats and in lab rats for human medicine research. So one of the possible applications we looked at was designer pets. As you saw in Lucas's presentation, you saw the green rabbit, the fluorescent rabbit. So, and also the eye color, you can change eye color, you can change fur color, you can change the muscularity of dogs and animals in general, and also maybe eradicate hereditary diseases. We all know the hip problems that Labradors have. We could maybe eradicate this. So a kind of exaggerated example of this, it's not superhuman related, but it is kind of a geeky thing. So we could maybe turn a lizard into a Game of Thrones dragon. To me, this would seem pretty cool to train such a dragon. But what if everybody would have a dragon like this, and it would grow up, it would start breathing fire? Yeah, that would be a problem. So we don't know if we change an animal, we don't know how our environment reacts to this animal, and also we don't know how this animal would react to our environment. Sorry. So it could maybe eradicate a species which is already present there, or it could have no natural enemies or such things. So before we act, we have to think, is this a smart thing to do with CRISPR-Cas? So another thing we discussed was GMOs in our food system. Many people are very scared of GMOs because it's an unknown thing. We discussed the matter of natural versus unnatural, and we didn't find a real clear definition of natural. So as you can see here, they kind of relate, but we found no definition that has been repeated multiple times. So people could argue that GMOs are not natural, but at the same time they feed their children with Nutrilon. Is this natural? It seems kind of hypocritical. And also GMOs are already present in our food system. So our cows are being fed with genetically modified soybeans. I don't know if any of you knew this, but yeah, it's happening. And so we wanted to propose something to give the consumers more insight in this GMO thing and in our food system. So we proposed a labeling system. So, for example, you have a carton of milk. It came from a cow which has been fed with genetically modified soybeans. And you could have a carton like this with a label which gives insight into the GMO behind it. So the last thing we discussed was using CRISPR-Cas on humans. And we could eradicate diseases such as HIV, as you heard. We could also eradicate cancer, maybe, and also hereditary diseases caused by genes, which run in the family. And yeah, we could make designer babies. But this relates to human rights, and Florence will now tell you more about this.
So this is a brief of our project that we did together. So what we thought would be interesting is to talk about human rights after, well, a little bit of our project. So yeah, I go forwards. So I was reading a leaflet a couple of weeks ago, and it was talking about human rights defenders. And so on it was talking about journalists and politicians and all types of jobs, but it wasn't talking about scientists. So I thought this was quite interesting because in the end, scientists generally work for the well-being of individuals' health, and also for sustainability projects and etc. So I thought, why are scientists not on it? And so what I'll discuss now is, scientists as human rights defenders. So this is Tristan Roberts, and so Tristan Roberts is a biohacker, which means that he's a decentralized scientist. So what he does is that he's treating himself because he is a carrier of AIDS. Except that there's no actual, treatment for it, which is, on the long term won't solve the situation. So what he does is that he uses CRISPR to inject into his stomach fat a plasmid so that his body will naturally produce N6, so an antibody that will keep his viral load low. And so what he does is that he publishes all of his findings on Medium in a very easy scientific language. And so the reason that he's doing this and why he's using CRISPR in a decentralized and unregulated way is because he believes that the medical system is built in a way which sustains for profitability and for patenting, and not necessarily for general well-being of people. Also, he lives in America, so obviously, as you know, medicine is very expensive and so not really available to everyone. And so what he's doing is using himself to treat, but also to show to others his research, whether if it works or not, how to do it. And so you can actually check him out on Medium right now, and his latest update is on the 25th of March. So for me, Tristan Roberts, in this sense, is a human rights defender because he's trying to push for better scientific medication in the field of AIDS. So in our group project, we also talked about CRISPR babies, as we had talked about before. And so what was quite interesting for us was that it was quite inflammatory. So we saw a lot of articles talking about how it was terrifying and how it was unethical, and well, a lot of people were very scared, and obviously it used a lot of kind of hype words, so CRISPR, for example, and kind of everything that's about gene editing, except that the issue about this is that most of these articles were probabilities because we didn't actually have much information about what happened to the babies. Whether they were or not genetically modified, how it was done, because not many people had access to this information. So this is just another case scenario of how academic research has been disproportioned into media or has been slightly misformed, and which means that the public is generally scared of it and doesn't really quite understand what's happening. So even right now, there's a lot of controversies on whether, for example, the babies have other superpowers and things like this. So this is not actually the twin babies. This is just some generic photo, but it's just to give a kind of human face to the baby. So a lot of people actually asked after the modification to, well, terminate the babies. But the question that I thought was interesting, as well as with our group, is whether or not genetically modified people should not have the same rights as ordinary people, and is not genetic modification the same as any other treatment such as chemotherapy, and how is it as different to anything else that we do to ourselves? So this brings along the question about human rights and how they differ with genetic modification, and why we have this slight terror of seeing people who are genetically modified as non-human, even though, well, we tattoo ourselves and we do God knows what with our own bodies, and why is it so different when we make a genetically modified treatment to it? So this is interesting in the case of Kilgrave. So he himself is someone who's been genetically modified, as told beforehand. And so during the series, he uses his powers in a very evil way, and so Jessica Jones makes it her priority to capture him. And so she imprisons him into, well, a pretty horrible prison, so not on your regular standards. So it's got electrified walls and water and etc., because obviously he's genetically modified, and so they have to find a way to capture him where he won't be able to use his powers. So actually, whilst he's in prison, his parents, who are the scientists who made the modification, actually came in and tried to kill him because they believed that they made a mistake during the treatment and they didn't expect this outcome, and so it was their responsibility to then kill him. So then Jessica Jones, in the beginning, she decides that she wouldn't kill him because she believed that perhaps she could use his gifts in a sustainable way, except that she realizes that in no way can she control him. So she makes it, well, in the end, sorry for the spoiler, he dies. So in the end, Jessica Jones plays the justice role in that. So this also brings about the question about if we're going to make genetic modifications, and if they go wrong, how are we going to solve them? And I guess it's also a big question about the CRISPR babies, because for now, the treatment seems pretty, it's just treating AIDS, if you think about it, except that if there are further modifications that have been made, should we not have an international way of dealing with these problems because genetic modification knows no borders. If you make a difference, it won't stop at the border of China, for example. So in this way, where He Zhuangku is actually imprisoned, apparently in his own apartment, and some say that perhaps he faces death penalty. I think this is interesting because in the end, we could possibly argue that maybe He Zhuangku isn't actually so evil as we think. So obviously, this is quite pushing it, but I'm asking the question, could we not see He Zhuangku as a human rights defender if we think about Tristan Roberts, in the sense where, yes, he made an illegal treatment, but in the sense where he actually used it to make good. So it wasn't to make the baby's eyes change, it wasn't to make them be able to fly, he simply changed something so that they would be able to be cured of AIDS. So yes, I would like to finish on that, to think about possibly scientists also as human rights defenders. And so in the case of genetic modification, because it's something that's quite controversial in the terms of public opinion, maybe it's up to scientists to introduce it to the public and also take that first step when public opinion isn't going along with it. So perhaps also we should see scientists rather as either good or bad, but trying to push for a better future and trying to understand what motivated them to do it. Thank you.
Thank you very much. And absolutely right on 12 minutes. You absolutely rehearsed that, right? Yeah?
Yeah.
Does anybody have any questions for Florence and Laura? Yes, we have a question here. Is the catch box there? Can we get that thrown? It's going to hurt someone someday.
Weet ik dat? Oh ja.
Yes.
Well, thank you for your presentation. Did you also study the influence on professional sports? Suppose we could modify people.
No, we didn't.
Well, we kind of did that, but we looked at horses, like the designer pets. We could make them more muscular, so in horse sports, it would be unfair maybe. And it could also account for humans then, obviously. Yeah.
Okay.
That's a really good question. So you should definitely come to episode 3.
Yeah.
I'm going to tell you right now. Absolutely.
It's my birthday, so.
Anybody else?
There.
Down the back, right down the back. Okay, so it's American football time. Oh, that's complete.
So I want to take the question that email and ask like. If we
Can you
start-
speak? Can you speak into the box?
Oh, to the box.
Yeah.
Okay. So I want to take the question that he made and ask like if we start changing people, like giving them the ability to run faster, jump higher, are we not gonna kill sports? It just run my mind now.
So, can I answer that question? Yeah. I think you should ask that question in episode 3.
Oh, okay.
Okay? I mean,
Okay.
any sports-related questions, save them for episode 3.
Okay.
Has anyone got any other questions? Anything else? No, there is another question. What I want to say as well is that, as I said, I worked with Florence and Laura on the project. They did such a great job. They were privileged to work with. I had the idea, and then they just ran with it. And also on the project in the front here is Stefano, who's there, who was Superman in episode 1, but he didn't decide to wear it today, and Willem over here. 4 of them together were a great, great team. I just want to give another round of applause to both of them and to those who were part of the project there. Well done. Okay, so I'm going to do one more question, and then we're just going to have a little bit of chat with everyone because we were running a little behind at the start. But very quickly, because this got me thinking about prisons for superhumans. So should we build special high-security prisons for any future superhumans who break the law? So answer is yes, normal prisons won't stop them. No, what about their rights? Maybe, maybe not. There will never be superhumans, so we don't have to worry about this. Yes.
What about prisons for people that build superhumans?
I suppose that'd be a normal prison, right? Or maybe they put them in the same one. Okay, so basically, most people here think that if we have superhumans, that there should be super prisons, effectively. Really interesting results to see. Okay, so what I want to do just before we finish is the following. I just want to sit down for a moment with all the people who spoke, because everyone here has got has some sort of interest and stake in CRISPR-Cas, but for different reasons. So, and genetic engineering. And I just want to ask, for example, go between all of you and ask, why are you so interested and motivated by this in your area, and what got you interested in the area in the first place? Yeah, life question.
Questioning my existence. Yeah, so I actually got really grasped by actually the science fiction part of it, because I remember the first interaction I ever had with genetic engineering. I must confess, when I started doing my study where you learn all this, I had no idea that bacteria even had DNA, basically. And I was just, there was this demonstration where they had bacteria and they were taken from fish and they lit up in the dark. And I was so fascinated by biology can do that, you know? And then they told me that I can even change that biology and do more. And you can, like, and during my studies, I learned that basically the possibilities are endless, and that just grasped me. And yeah, I just want to try and see the limits of biology, but for the greater good, obviously, because yeah, I also got grasped by the political climate of climate change and all that. And I think biotechnology is the field that is hopefully going to save our climate, save our whole medicine structure. We can tackle genetic diseases with it. So all these possibilities really made me want to learn more about this and see how far we can go, and how we can use this technology to kind of make bacteria that light up, but also yeah, use it for real-world application and really make a change.
So then from your perspective, it's really important for you to work with someone like Britta, who's coming in from the bioethical point of view on innovative biotechnology. So then for you, Britta, what has motivated you to focus more on that side rather than, for example, like Charlotte has done in terms of being in the laboratory every day doing the experiments?
Well, I first want to stress that I do focus within my work on gene editing techniques, but that doesn't necessarily have to mean that it's only CRISPR-Cas.
Of course.
Of course. So I was also always very interested in biology, but for some reason I chose to study chemistry. So I studied chemistry for my bachelor. And during my chemistry program, I always kind of missed the link towards society. So we're doing a bunch of stuff in the lab, but eventually it is being implemented in society. We're doing it with a certain purpose in mind. We're scientists or researchers for a reason, to mean something, to contribute something to society. So for my master's program, I chose to study innovation sciences, and I also focused on more of the ethics and philosophical questions related to science and technology. And then during my graduation, I saw this project coming by. During my master, I was still located in Eindhoven, so after I graduated, I made the transfer coming to Delft, overloper. But I don't know, since I was a child, I always wanted to do something, and it sounds very cheesy, I'm aware of that, but just to contribute something, do something good for other people and maybe even for the world. And I think that as I already mentioned in my presentation, I think CRISPR has a lot of potential to actually contributing something to society. But it doesn't mean that we shouldn't be very careful with it, because it can also be abused.
Absolutely. So I'm going to ask you a hypothetical question. Let's imagine...
It's also part of my job.
Yeah, hypothetical
So
questions. This is really hypothetical. So one of Spider-Man's main villains is the lizard, Kurt Connors, who does a self-experimentation to allow him to grow back his arm. But one of the side effects is that he turns into a giant lizard when he grows his arm back. What would you say to someone who has, in my eyes, demonstrated quite unethical practice? What would your advice to be to somebody who wanted to try and do a Kurt Connors in science? So someone like referring back to Hay in the CRISPR babies, what would you say to them if you had the opportunity before they did the experiments?
Well, I think there's a distinction between the applying it to yourself very consciously and being applied to when you're not aware of it, in terms of the CRISPR babies. So if I, for example, would decide to alter my own genes very consciously, I think that should be allowed, but only if that person is also willing to accept all the responsibilities that come along with that. So not only the positive side effects, but also probable negative consequences, not only to him or herself, but also for other people's. So if you can totally agree with that and account for all responsibilities that come along with it, I think, well, this is of course a hypothetical situation, so I can say whatever.
Yeah, you're
No, I'm
among
kidding.
friends here. You can say no one's going to judge you. No one's going to affect your...
Well, I think responsibility plays a major part here, and that is also something, it's very difficult to take or accept being responsible for something that you're not even aware of that it might happen. So I think that's where the problem, and that's where the tension lies.
Okay.
Can you be accounted for something that you're not even aware of that it might happen?
I'm guessing, given that you work in a biotechnology department and focus on ethics, that the people you work with might actually be surprised if you entered into the office one day and said, guess what, I've been experimenting on myself with CRISPR-Cas.
Yeah, they would be quite surprised.
Yeah, I think so
yeah.
too. So then, from the other side of the coin, in terms of the artistic point of view, Lucas, you're using many, many different approaches. Will CRISPR play a part in your future endeavors, or is it playing a part right now in what you actually do yourself?
Well, it does play a part. I have an interest and that's what my work also comprises at Waag. We have an interest to look at the way new technologies land in society, and how these are perceived, and how you can possibly let them land otherwise if you not only in the decision-making process about what technologies are we going to use, work with ethicists, but also work with the public, because the public is always brought in as the lay people, which I think is a misconception. I think the public is an expert in living its own life, and they are not the people that are handicapped by not knowing. I think the experts are handicapped by knowing and having difficulties to bring across what they know to an audience. So I think new constellations are needed here, specifically what Britta is researching. I think that is very important. And it's not only techniques with a big impact like CRISPR on ecology and on human health, but also other technologies like artificial intelligence and the whole complex behind that, what we are looking at. And talking about this, the way that is research in what kind of implications it has for society. We work with artistic researchers in that fundamental phase of not looking at what it fundamentally can do, what fundamental kind of knowledge is derived from a specific research area, but also what form it takes. And those forms are shaped into artworks that make those technologies tangible for us, for the public. And we ourselves as individuals are also always both part of the public, but also part of an expert team. So we change roles during the day. In the evening, I'm a father. In the weekend, I'm an activist against climate skepticism, and during the weeks I work on technologies. So I think we should be very aware of that in order to make those technologies more inclusive.
Okay. So I think
artists can do a very good work there.
I also agree. I mean, I think I'm not going to say that I would have been very artistically minded my whole life, but in recent years, because of my involvement in and doing events like this, I've met lots of people who have opened my eyes up to the possibilities, and I very much admire what you're doing. And be sure to tell us about what you're going to do in the future when your next art piece comes on out. We'd be very, very interested to.
Well, the
promote it.
next edition of Binge Watch Academy is going to be about Flash.
The Flash, the Flash.
Yeah, we've been making Flash, in vitro Flash with the people, with the public in the lab.
Okay.
As part of a big dinner.
Okay.
In order to understand the ethics of meat eating. I think that's important.
Okay. And finally, then, because both Florence and Laura, you're taking the first steps in your career, where you're going to go, and just tell the audience what you did is for what you're doing for your bachelor's at the moment. You're in the bachelor's, right?
Yeah.
So, Laura, you're doing?
I'm doing biopharmaceutical sciences, which
Okay.
is basically discovering new medicine. So CRISPR-Cas for me is really, like they said, it's really a big breakthrough. And I feel like it could replace like a lot of medicine at the moment, and even better than. So I'm really interested in CRISPR-Cas, and I really hope in 2 weeks I'm starting my thesis. I really hope I could do something with CRISPR-Cas. I'm not sure if it's allowed, but I hope so.
I hope so too, because I think that from the area you're in, that where you are at and how CRISPR has evolved and kind of exploded in its use in the last 6-7 years, that in your area it's going to be hugely, going to play a huge role unless something else comes along. And maybe, will something else come along, Charlotte? Do you think that's like CRISPR-Cas?
Maybe.
I mean, it could.
Yeah, I mean, right now where a lot of researchers are focusing on really improving CRISPR-Cas, also adding like extra modules to it, or finding new CRISPR-Cas. For example, recently researchers now start looking in very extreme areas, for example, in volcanoes and stuff, and find bacteria that have then a CRISPR-Cas that can function at 50 degrees, or so they're trying to make like improvements on CRISPR-Cas, but maybe someday they will find something that's even more precise, more, I mean, there's still a lot of unknowns in the genomes of bacteria, and there's also weird bacteria living on the bottom of the sea that we've never even, isolated from there. So who knows what they do to their genome to protect it from the weird circumstances there.
Whatever is there in their environment.
Really, it might be.
So for someone like you, Laura, with your career going forward, if you were going to work in CRISPR, what would you want to try and do with CRISPR?
Well, I think the biggest issue right now is like heart diseases and cancer. I guess more towards that area, because you can get the most people with that. So, yeah, I think.
And the most important thing is have fun. Right?
Yeah.
I mean, that's it, right? Whatever you're doing, enjoy it. And what you just mentioned there could have a real positive societal impact, of course.
Yeah.
And what I think is most interesting about your group, because your group that you had in the minor for responsible innovation was mixed discipline.
Yeah.
And Florence comes from like a completely different area. What is your area of work at the moment, your bachelor's on?
Yeah, so I'm doing international studies focused on Europe, so completely different. But at the same time, extremely interesting with GMOs, if we're looking into Europe.
So how did you, for you, because Laura, of course, working is doing a bachelor's in the bio world, how did your perspective on biotechnology, on bioethics, on CRISPR evolve from where you started to when you ended in the project?
Initially, I thought that GMOs were always bad. If I'd have seen someone say, oh yes, GMO product, I would have never bought it. But after the project, I would, without hesitation, probably buy it. I think that especially, the sphere that I'm really interested in is European culture with genetic modification, and why we choose to import it for our cattle, but prefer not to make it over here.
Okay.
I think that's very interesting.
And for you, what do you envisage for the future, given that you're starting out on your path with your career?
I guess write my thesis on EU legislation and GMOs, and then see from there what happens.
And has that choice been motivated by doing the work on the project?
Yes, definitely.
Wow, that's great.
Yeah.
That's really cool.
That's really for the audience. Maybe if there's some students in here who still have to do their minor, really look into the responsible innovation minor. It's really, really worth your while. So, yeah.
Thanks for the plug. I didn't tell Laura to say that. So that was a really nice discussion, I have to say. Just a way to get everyone to get to know a little bit more about the speakers. So we're nearly at the end. But I really got to point out this film that's coming out in the next few weeks. Now, yeah, Shazam is out this week and Hellboy is out next week. But I can't get past this film, to be honest. This is Avengers Endgame. If anyone hasn't seen it, Avengers Infinity War, I'm not going to mention anything because, yeah, things about why these posters look like this. But if you want to know who the characters are, that's, of course, this is Black Widow, played by Natasha Romanoff. That is Rocket Raccoon, voiced by Bradley Cooper. And that's the Vision, the guy who was mentioned in Britta's talk with the Mind Stone in his forehead, played by Paul Bettany. And then there's all these other characters in the film as well. The posters are coloured for a particular reason, which I don't want to give away. I just want to add, you heard us all talk here, and you heard all the speakers. There's going to be a podcast episode coming out in the next week where I'm going to sit down with them all and have a discussion about today's event. So you'll be able to listen back to what everyone has said and hear a little bit more, and maybe things we didn't get a chance to talk about. Next time on Binge Watch Academy, we're going to talk about Supergirl and The Flash. We're going to be talking about speed, so any of those sports-related questions, bring them along for the next episode. 4 of the speakers are in the audience somewhere. I saw 2 of them there, and there's 2 over here have their hands up. So there's 4 of the speakers there, and we're going to be taking different perspectives on speed and how we could, in fact, well, perhaps run like the Flash or fly as fast as Supergirl. Just to remind you that next episode, episode number 3, is on April 25th, right here in the Owl Auditorium, same time at 7:30. And as I say, the focus will be on those 2 characters that I just mentioned. This has been Binge Watch Academy Superhero Science, episode number 2, focusing on the genetic engineering, Jessica Jones and the X-Men. I've been Barry Fitzgerald. These have been our wonderful speakers. Thank you very much for being here this evening. Thank you.